Hey everyone, this is Matt with Learn Everything About Design. And in this episode, this is part 4 of our reverse engineering this Airbox series. The fourth and final part, as I mentioned in the last one, we're going to go to the end with this thing. So I don't know how long it's going to take. As you probably are aware, in nearly all the videos we do it live in real time. I haven't pre-modeled this thing, so I'm making these decisions as we go along and kind of explaining my thought process as we do. So in this video, if you haven't followed along with the previous 3, I do suggest you start from scratch. But if you had any trouble, I will put a link to the data set that you see on the screen. So if you want to start there, you can. As sort of a recap, we started this with some basic shapes to get down to what I'm considering close to the scanned part. And then we made sure that we understood that this is a part we're designing for 3D printing, and it's not going to be injection molded. So we could kind of discount any of these design requirements for injection molding. We don't have to worry about draft or keeping things a consistent wall. It is going to be 3D printed, but we still need to maintain accuracy of sort of the original design intent and features. You can see there are some areas where we're a little bit off. For example, this flange is a little bit low, so these are things that we can change and adjust, and we likely have to make some adjustments before we go too much further. But overall, our focus has been on the concept shape or the original shape, creating a thin wall part, and then beginning to add additional features like the inlet, mounting points for things like the mass airflow sensor or some of these other bits and pieces that are on the side. Because the design is meant for 3D printing, we're not worrying about creating features that are consistent thin-walled or designed for injection molding, for example. Because I don't actually have this part, I was just provided the scan by a subscriber, I can't look at the real thing, so I have to make all my design decisions based on the scan. So in this video, we're going to focus our attention on finishing off the internal features. We are also going to add some external features. As I mentioned, I don't really know what this piece is. It looks to be some sort of clamp, likely a harness or something going through there. And we're going to try to add all the rest of the features that we need. Let's go ahead and let's talk a little bit about the discrepancy in this sort of mounting flange now, because this is something that we need to take care of before we get too much further in. Now, if we find where the shell feature is, which is right here, that is kind of like halfway down. Now, if we just roll this thing back to the shell, we can see that the top area of the flange doesn't really go to the top portion where it should be on the scan. Now, the bottom is fine. You can see that we're kind of here, but the top does not. So an easy way to do this is to figure out which feature was used to create it. We could go back and find an extrude. In some cases, you can right click and find in the browser or find in the timeline if you're clicking on a feature like a fillet or something. In this case, the easiest thing to do is, again, kind of work in that history-free direct modeling approach. So I'm going to use press pull. I'm going to say I want a new offset, and I'm just going to pull this up. I'm going to go to a right-hand view. I'm going to pull it up until it's where I think it should be. So it looks like right around 4 millimeters. And we're going to say OK. Now, after this, if we do our shell, this should automatically fix everything else. So you can see we're probably 1/4 to 1/2 millimeter off. So we can adjust this. Instead of 4, we could do 3.5. And this is the beauty of this somewhat hybrid workflow where we are using some dimensional inputs, but we're really focusing our attention on recreating the shape without worrying so much about fully defined sketches. Whenever I'm doing a part like this where we're really focused on, let's say, something like a one-off reverse engineering job for 3D printing, I don't waste a bunch of my time adding dimensions to things that don't need it. Now, if parts need to fit together and we need to, say, have a 0.2 or 0.4 millimeter gap if we're 3D printing parts, yes, I will 100% put some dimensions in for that. But if we're trying to get a loose approximation of this, make sure that an air filter fits in here, make sure that these features are in the right location, we don't really need to spend our time, adding dimensions to everything. All right, so now that that's been adjusted and taken care of, the next thing that I want to do is I want to focus my attention on these internal features, these ribs. Now, as I mentioned with these ribs, there are thin walls, because typically when you have an injection molded part, the taller that wall is, there are potential issues. Like the draft angle needs to be steeper and it ends up getting really thin and creating sink marks on the main part. So what you end up with is this really tall tapered wall. And then you get these vertical ribs that get added for structure, for one thing. But they also end up getting added for places where you can have ejector pins. So these round sections, likely there were some ejector pins for this. But what we're going to do is we're going to focus on the intent here. So we've got this somewhat of a cage that needs to catch a filter. And then we also have this wall here. And I don't know if it was a baffle or what was here originally, but we're going to recreate it either way. Again, we don't have to be perfect here, but we're going to get the intent down behind it. Now we do have a couple of faces. So like this face here, we can use as a sketch plane. We're going to make sure that we're on orthographic view. So this will help us make sure there's no distortion. Whenever you're on a plane that's not your standard front, top, bottom, right plane, then having orthographic with perspective on can actually be problematic in trying to figure these features out. So another thing that we want to consider is that these walls, they may need to hit other features at a certain spot. So I'm going to rotate this around a little bit. So you can see we've got this wall is kind of encompassing this feature right here. That's okay. I'm going to bring it back over here. That's okay. And what I'll likely do is make this wall thicker, because with 3D printing, it's not going to be very strong, a tall, thin wall like that. So what I'm going to do is use a 2-point rectangle. I am going to draw this past the inside of the housing. We could use something like intersection, but we're not sketching directly at the height it needs to be. So I'm just going to kind of exaggerate this. So I'm going to come down to here. I'm going to do another 2-point rectangle. And then we're going to do the same thing kind of over here. And I can adjust this. Again, leaving it underdefined will allow me to adjust it. This wall is flexing and deformed. Likely in the real one, that's not the case. And then I'm going to go, let's say, from here, and I'm just going to come over here. So some interesting things that we need to do. I'm going to hide the airbox and the solid body for now. I'm going to use collinear to make sure that these two are collinear. I'm going to do the same thing down here as well. So that way that as I move these up and down, I can make them thicker. Again, in the scan, we really want to focus our attention. I'm going to make this wall as thick as that section there, but we want to focus our attention on getting these features in the right location. So obviously there's some sort of filter housing that needs to sit there. I'm going to take, if we zoom in, I'm going to convert that to construction. That simplifies the selection process. We'll do the same thing over here. Make sure that we don't have too many edges. And there's a little section, it's probably from the original wall. So we'll hit X there to clear that out. We'll hit X there. That will simplify that. All right, so I'm going to add a dimension here. So D on the keyboard. I'm going to say 5 millimeters for this wall. I'm going to do the same thing over here. Let's find where it is. All right, we're going to click on this one to make them equal. And then go back to our scan. Hit Escape and maybe drag this out. And we can set this at 5 millimeters as well. All right, so in terms of the location of this feature, if this is critical, let's say from some reference edge here, then we do want to add a dimension. Let's say it's 22 millimeters. I don't know, I'm just making this up. And then this one here, we may want to make sure that it's at least 5 millimeters, and we'll maybe do the same thing over here, make it 5. And then decide where we want these edges to be. For our purposes, I am going to leave it underdefined. And I've been doing this kind of the whole time, right? So I'm going to leave it underdefined so that way I can adjust it. And then if I have to, I'm going to go back and make those changes. So with it underdefined, let's go ahead and extrude. I'm going to grab all the regions that I'm interested in. And then the first thing I want to do, notice that it's at a different angle. All right, so the face that we selected was at a different angle. So as I pull this up, what we're going to notice is that this right here is starting to pull away from the airbox. And then if we do two sides, as we go down, this is starting to pull away from that wall here. So I'm going to say okay to create a new body. And part of the reason for this is, one, these are not in the right orientation, like at all. So that means that my sketch plane was flawed. That's okay. What we can do is we can change the sketch plane. This is possible by going to the sketch, right-clicking, and saying redefine sketch plane. But what we need to do is we need to pick a plane that we want to use. So for example, this top plane. The problem is we're going to lose the projection, or we're likely going to lose the projection. Notice how they sort of flipped sides, and this happens from time to time because the normal direction of that sketch or the sketch plane that we used is now different. So this means that we're going to have to fix it or change it or something like that. The other thing that we can do is we can just rotate these bodies and kind of move them around. It's not ideal, but it is certainly possible. The third option that we have is we're going to roll back before the sketch. And what we're going to do is we're going to create a section view, section analysis, and we're going to flip the sides and say, okay, so this section analysis lets us go through the mesh. And then you'll notice here that we've got this wall, that rib that's going up, it goes kind of up and then tapers down. So even the rib itself is not completely normal to the geometry, but what we're going to do is create a sketch, and we're going to use that same technique, that sort of straight line, and then we're going to create a plane that's rotated about that or directly located on it. Now we could do this with an offset plane, or we could do it another way, but sometimes, especially if the geometry is kind of at a funky angle, you might find that you want to do this. And now, hopefully this works. What I'm going to do is redefine the sketch plane, and I'm going to select this and cross my fingers and hope that it keeps it the same. And it does not. Of course it doesn't. That would make it too easy. All right, so what we're going to do is I need to fix the sketch. So that's okay. It happens. All right, so what we're going to do is basically this needs to be over here. I'm going to delete that 5 millimeters and just drag that way. Again, because we left everything underdefined, I'm going to go ahead and pull that over here, pull this over here, and then delete some of the dimensions that we don't like. So some of the ones that were projected. So I'm going to pull this over, pull this up. Let's hide the mesh for now. If you see anything that's like green or yellow, typically what happened was that was a projected reference that got deleted. So just go ahead and we're going to make this bigger than we need to. We'll drag that up. That looks like it's in roughly the right place. That's in roughly the right place. And make sure that it extends outside the airbox and say okay. All right, so now we're a little bit better. We're going to extrude. The top doesn't need to be nearly as big, but we do need to go past that wall there. And then the bottom, I'm going to go kind of all the way through the bottom. Now you might be thinking, okay, why am I doing this instead of like extrude up to body? That's a very good question. We certainly can, and let's hide these for a second and hide the sketch. So on this side, we could use extrude up to body, and actually it's probably a good idea to do it here. On this side, however, because it's flat, it kind of goes up and then comes back down. If that's an important feature, that's something that we need to account for in a different way. And it becomes a little tricky to do if that body or that rib is integrated into the main airbox. So let's go back to this. Control, select all these. For distance, for this one here, I'm going to say to object. And oh, I guess it's not going to work because it's outside of the profile. So, all right, we'll just deal with it this way. The reason it didn't work is because I made this profile way outside. I would have to drag this one in to make it work. It's certainly possible, but this is going to work out just fine as well. So I'm going to turn the analysis back on, hide that body, and then from the side, what we're going to do is we're going to take a horizontal line, going to come up, green check mark is always in the way, and then we're going to come out this way. And again, I'm just kind of trying to get it close. I'm not worried about precision for what we're doing here. We'll bring that back, hide the analysis, hide the mesh body. All right, so now when we do split body, we want to split this body, use this sketch, And this is going to leave this little top piece here that we can get rid of. So right click and remove. Now there may be some like lingering overlap pieces. So like if I select that and hit Q for press pull, we can kind of move it. And as we move it, if we click on a spot, it'll automatically measure that dimension for us. And then if I delete that face, sometimes it does a nice job of patching it. Not a big deal for this part, but it seems to be working okay. All right, so now we have to deal with getting these to fit together. Now there are a couple tools that we can use to make this happen. One of them is just split body. We can use one body to split another body. That's totally fine. Another tool that we can use is boundary fill. Now boundary fill is helpful in cases like this because we can select all the cells, which are going to be these 3 solid bodies, and then we can select the pieces that we want to keep. So the center is going to be the main part of the airbox. And then we've got this upper section of this wall. This extra piece, it's kind of hard to see. This tool doesn't really have great UI, but the second piece is like the thin overlap or intersecting section between. And this last little piece here is the part on the outside. You can actually select the bodies as well. It's obviously a bit different or difficult if they're inside the wall, but basically what we're going to do is keep everything except for those 2 outside pieces. We can do this as a new body, and we can select remove tools. So if we say okay, what we should be left with is a single body, and all those pieces from the outside are gone, and these are now attached on the inside, which means that we can do things like apply fillet. So if I say F and I start to, round these corners off, let's say round that top corner off, apply some fillets to some of these edges. So we can kind of just do all this stuff to smooth it all out. That is probably the easiest way to approach those like multiple overlapping bodies. Again, you can use things like split, you can use surfaces or solids and keep the overlap or the intersecting sections if you want, but boundary fill comes in pretty handy sometimes. So let's go ahead and save that. And let's take a look at the mesh. So the mesh has this extra little piece here as well. Again, without having the airbox, I don't really know if this recess piece part up top here is basically a feature of because it's injection molded or if there's like a clip that has to go in there. So because of that, I would likely create something relatively simplistic, and then the user that is going to be using this or 3D printing it would have to decide what features they want. So again, the way to do this is to think about things like planes. So if we've got a plane here, actually, you know what? Let's use that plane. Let's create a sketch on this plane. We're going to use slice, and it gives us a pretty good representation of that feature. So when we've got this vertical wall that we created. So what I would do in this case is go to project, include, and intersect, and likely grab the geometry that we're intersecting here. Now, of course, there's an opening where the inlet is. That's something that we need to be kind of aware of. It's slightly different than how the actual mesh is. But what I'm going to do is I'm going to start from that intersection point. I'm going to come up, and I'm going to come over to this wall, and I'm going to finish the sketch. So because this is a closed section, we can just extrude it. I'm going to go this direction, and it should be a mid plane. So what we can do is we can say symmetric, and then just get it, get it close there. That's going to join together. We'll say join. I'm going to hide the mesh. And again, then we would likely want to apply some fillets, kind of round everything off. Let's go ahead and just grab all the edges. This one down here is likely going to fail just because it's intersecting with this edge here. Now, in reality, what I would probably do, it looks ugly. In reality, what I would probably do is make some changes or adjustments to the geometry right here, just because I don't like that sharp edge. But for the purposes of what we're doing here, I think that's okay. So I'm going to leave it like that. But again, on the scan, just need to decide, is this dimple a spot where whatever slides into here that has a recess, and if that part's getting used, whether it's some sort of mesh screen or pre-filter, does it pop into that, and how do you need to recreate that? So those are the decisions that we would need to make. But as far as the inside goes, I think that recreates everything that needs to happen on the inside. Now on the outside, again, I'm going to skip this piece. It's likely way more complicated than it needs to be for what I think is probably just a cable catch. You could just put a little tab there for a zip tie, and or even run some holes through other little pieces and run it up. So we need to take care of these large pieces here, the latches, and then address these ribs. All right, so as I mentioned before with these ribs, this is something that when you're 3D printing, you don't need to make a bunch of little ribs because we're not kind of constrained by the injection molding. So what we can do is we can actually just make a chamfer on the bottom, 5-6 millimeters, 7, looks like 8's probably about the max that we can go. You can also change this. Instead of equal distance, we can do 2 distances, and we can make it come up a bit taller. And essentially, when we've got something like this, when we're 3D printing, that's going to give us all the support we need. And again, if you're doing an infill in here, this is 3 millimeters thick. You can set up the number of walls so that you're printing the upper portion solid, and then you've got a slight void in here with some sort of infill. The outside and inside skin of this will provide all the structure you need. And then you've got these, the extra section in the middle can be printed as hollow, because if you're using an FDM machine, that's perfectly fine. So that's what I would do instead of trying to replicate all these ribs. It's just going to be something that's nasty to 3D print, and it's not really needed. Now, as far as this right here, we're going to go ahead and create a sketch plane that's offset. So I'm going to grab this plane, and I'm going to get it close. I don't know exactly where it needs to be, but once I have that sketch plane, I'm going to resize it. I'm going to pull that up and figure out where it is. It looks like it's actually ended up right in there. So we could use a mesh section sketch now on that. So mesh section sketch, we're going to use that mesh body. The section plane will be here, and we'll say OK. And then we'll edit the sketch. I'm going to hide the mesh body and the solid body. And then what we can do if we want, we can fit curves to mesh section sketch. I don't think it's really needed, but let's do an arc. Let's say from maybe here to there. And then hit escape. Oh, that didn't work. Sorry. Let's do mesh section sketch arc from, say, there to there. And I'm going to hide the plane. The plane's what's really messing this up. All right, so now we got an arc for whatever hose needs to be in here. And again, when we do stuff like this, I'm going to just get it close. It doesn't need to be perfect. Let's just draw that there. And we're going to use some trimming. I'll just make it vertical. And we'll come back to there. We're going to use an intersection with the solid body as well. I'm just getting it started. All right, so we'll use extend to extend the arc out in both cases. And I'll go ahead and extend that out as well. And then we'll use the trim tool. So just hold down the left mouse button and drag that. We'll trim it over here, trim it there, and up there. All right, so again, that's pretty close. We can expand and hide the mesh section, bring back the solid body. I'm going to use slice to kind of see what we're working with. And then we'll go to intersect. So I'm going to select the entire body. I don't need to, but it's just going to be easier for our selection process. And then I will trim this. Because we didn't worry about basically creating anything with draft or any complex curves on the outside of this thing, I know this section is planar, which means that I can just extrude this profile. So if we pull it this way, let's go ahead and make it two-sided. Oh, I added a bunch of Z's in there apparently. Let's go this way. and then we'll join them together. All right, so hide the mesh, and now we got that little tab. Once again, not injection molded. I don't need to worry about consistent wall thickness, so that makes this process quite a bit easier for us. If you were trying to make this consistent wall thickness, then we need to do some recesses. I'm going to start with that as a fillet, and then I'm going to repeat that again. I'm going to round these off, and I'm going to say, okay, this is a sharp corner still. I didn't actually do any fillets there. I'm going to go ahead and it's not liking that up there for some reason. Maybe there's a gap there. Not sure why that is not liking it up there. Let's do so we've got a construction plane. Let's do a quick section view here. Sometimes you'll be surprised. Well, yeah, so here's the problem. If fillet doesn't actually happen, even though it's very minor, there is a little bit of a gap there. And I do see this from time to time when people send me files. That gap is very, very minor. It might actually not even cause a problem in the 3D print, but it does mean that we should go back and we should adjust this sketch. So what I'm going to do is I am going to extend, let's go ahead and extend that to the inside edge. The bottom one was fine, but we can extend that to the inside edge as well. And then go back to this extrude, and I'm going to select those profiles and join them together. And then double check this with section analysis. All right, so that looks okay now. All right, so now we should be able to add a fillet here, no problem. And I'm going to carry this down around the bottom. I don't care about the sharp corner. Again, not really worried about manufacturing, but now we got that tab. And once again, if you're 3D printing this and you've got enough walls for the 3mm print, this would just have some infill or some voids on the inside. So making it solid like that is not really a big deal. Let's do a quick save, and let's bring back the mesh, and we're going to basically repeat the process over here. Now, this side might be a little bit tricky because this goes into this kind of weird recess. It's not a planar face like we were dealing with before. But let's go ahead and just drag a plane over there. And it actually looks pretty good. That'll be a good starting point. All right. So once again, we're going to create a sketch. I'm not going to worry about a mesh section sketch in this case. I'm just going to manually draw it. So I'm going to grab a circle, get it to be approximately the right size. I'm going to go up, over. This one I'm going to draw way bigger than it needs to be because we're going to use that boundary fill tool. And we'll come in here. And then we'll use our trim tool, which is T on the keyboard. All right, so now we can extrude this. I'm going to go this direction, 8mm, bring the solid body back, and we'll create this as a new body. So once again, the main reason that we're doing this is because this face is angled away, and we can't really create an extrude that works here. If you did this face first, you might be able to do extrude up to body, but likely you'd be left with a little bit of overlap. So once again, tools like boundary fill, if we select these, we can select the outside, the portion that's in the wall, and this piece here, and we can just get rid of that. Removing tools will delete all the extra bodies, and then these two will be combined together. So we can add the fillets like we did before. I'll select all these edges. We'll say 1mm. Okay. Fillet these, we'll do 1mm also, and then round those off. All right, so once again, we didn't use a mesh section sketch. We didn't, create an exact copy of it, but it's the same geometry. We can resize this if we need to make it bigger or smaller, and we got the intent of it down. So the last thing this really needs is going to be some of these little sort of lip features. Now, once again, this is where we really need to look at this and say, okay, well, what part of this was created because it's an injection molded part? So basically these pockets here are open because it's injection molded. These ribs here are there for structure because we couldn't just make this a solid block. Now, in reality, I don't know if just this bottom tab piece is the important part or if there's a clip that goes over the top. So what I would do is basically create this bottom tab piece as one whole block, and then we can remove material as needed. So the way to do that is I'm going to create an offset plane. I'm going to create one of these things, and then we can just duplicate it or mirror it. So I'm going to start in the middle of this. And again, I'm just eyeballing it. You can spend as little or as much time as you want making everything perfect. For our purposes, I think that eyeballing it is good enough for what we're doing here because you are not going to be using this file, right? I mean, you're not going to 3D print this file. So what I'm going to do is I'm going to just start laying this out. At this point, I'm going to hold down the left mouse button and draw an arc. Then I'm going to come up to, let's say right here, draw an arc, and then come straight back. Again, it doesn't need to be perfect or exactly match, but the important part here is we want to make sure that we maintain like a tangent relationship between these. And then I'm going to hit escape to get off the constraint tool. And I'm just going to pull this down, maybe make that arc a bit bigger, pull this one up, pull that up. Again, these are like, sometimes when you get these blended sections here, partially it's based on the way the scan was done. And what I mean the way the scan was done is getting in these sharp corners can be tricky. So sometimes they end up getting rounded when they're not actually rounded. So now we're going to hide the Airbox scan. We're going to bring this back and we can see the geometry that we're working with. So we can go to project, include, and intersect. I'll just once again grab the whole body. And I'm going to leave these overlapping and I'm not going to worry so much. Actually, we'll just pull that one all the way through. I'm not going to worry so much about creating a nice perfect sketch. I will trim these on the outside. But again, you notice that I didn't do any dimensions here. So extrude, we'll go this direction. We'll say symmetric. It should be the same on both sides. And we'll join it together. All right, so I'm going to do a fillet. I'm going to start by doing a fillet here. We're going to say OK. So that gives us that bottom geometry. And then if we need to remove material, again, we can do this with a sketch on the side. So for example, if I needed, let's see, this recess here for, let's say there's a clip that goes in there. Again, I'm going to leave everything underdefined. If you were trying to create this, I know I keep saying this over and over again, but if you're trying to create this, you may decide that you actually want to dimension everything. So I'm just going to pull this back until I can see this this on the inside. We'll say OK. I'm going to mirror that feature. So we'll say mirror feature, that one. It's going to be about that last plane, the plane that we used to create this. We'll say OK. And so we were able to cut that out. So now we can add some fillets. Nope, I think I selected the entire body. That's going to be messy. All right, we'll drag those down. Those have sharp corners on them. Let's hide the mesh. Make this a bit easier. Yeah, so that's essentially the geometry, but you would likely want to do maybe some additional fillets, like in these corners. Let's do that one there. And we'll do the same thing over here. Maybe even grab that. Just kind of round those off. I'm going to undo those last two, simply because when you go back, it's going to be much easier to have it sort of respect tangency. Then we can go around go around the whole thing if we want. Let's go ahead and leave that. All right, so that's essentially the the feature. So in order to get this on the other side, this could be a little tricky because this one kind of rolls around the edge, but we could take the same exact sketch, this first one here, and we could try to extrude it. But what we would want to do is offset it. So let's say 50 millimeters, and then let's say 10 just to see where we're at. So it's probably more like 100 millimeters, 115, 125, 135. All right, so now we're getting close. So you can see that we can build that. Let's see. We can build that feature there. This is where it's going to get a bit tricky because how it rolls around the corner. So you may find that you actually want to include all that other stuff and join it together. If we bring this back, it actually needs to go a bit further right, so like to here. And then what I'm going to do is grab this face and say press pull, and then just pull it 4 millimeters that way or 5 that way. All right, so that kind of helps simplify it a bit. I'm not going to, let's go ahead and hide this. I'm not going to recreate any sketches, but again, we can use extrude and we can take that. We're going to say start from object and we can pull it in. I think we went 5 millimeters. We're going to repeat that. We'll say start from object, go in 5 millimeters. And we didn't have to, we didn't have to recreate a bunch of stuff. So next we would just need to go through and apply all these, all these big fillets. And so round them off. Can't remember if I used the same size there. I did not. All right, so we'll say okay. And I think these were all 1 millimeter. So just work your way, oh, not that one. Work your way around, add all the fillets that you deem necessary. We'll go ahead and grab these ones here. And that one. And then we'll say one there, one there. Nope. We'll grab those and just grab a couple more. All right, so essentially we built out the same features. We got that little latch on the bottom. We got the recesses on the side. And again, this is, I can't say it enough. We're not trying to recreate the injection molded features because they're not needed. What we're doing is we're recreating features for that are needed for fastening, and we're not so concerned with like thin wall. Now, if you are, you can of course go back and cut things away. Generally, that's a little bit easier by creating a body and doing things like shell or cutting away before you join everything together. If you do an extrude and join things together, it becomes a little bit trickier to extrude back down to these original faces. But for the most part, it's not that bad of a process. You just have to kind of pick your order of operations. So as I mentioned, the last thing that we didn't really address was this thing because, again, it's a big complicated feature for I think what its function is. It'd be much easier to just put a little tab there. These little pieces here, again, because of injection molding, have a lot of stuff going on. In reality, what we could do is figure out where they are. I'm just going to use the line tool. I'm going to go there. I'm going to go there. And we'll do the same thing over here. So line and line. Hide the mesh, hide the body. Trim tool, so T on the keyboard. Kind of get rid of these. Once again, you can apply dimensions if you know them and need them. In this case, I don't, so I'm not going to. We'll bring back the mesh. We'll say extrude. And let's see how far we need to pull this down. And it looks like about 3 millimeters. Hold down Control and include that. Bring back the solid body, join them together. And then we can round them off. So fillet, I Again, these little dialogues are always in the way. I am going to be doing sort of a Fusion gripe video in the near future. Things that I wish would be fixed and features I wish would work differently. So if you have any gripes, keep an eye out for that video and you can add them to the comments. But for right now, here we go. And anything else that you want to do. So if you want to round off corners, add little fillets in places to kind of get rid of these sharp edges, you can certainly do that. Not really needed for a 3D print, but for the most part, there you go. Probably last feature would be screw holes or mounting holes for, create selection set, for things like mass airflow. So what I'm going to do is project that face, again, orthographic, and then we're going to do a circle. So if there's like a screw that's like thread forming, you would just need to pick the appropriate size. It's probably like a 4mm hole. I'll make these the same, make them equal. And then again, because it's not injection molded, we don't need to have a taper. We just want to make sure they go down far enough for the screw. We'll say okay. And there we go. So obviously there's a lot on this part that I don't know. I don't have it, so I don't know exactly the intent of some of the features, things that may be needed or may need more detail, like this, for example. So I didn't include a hole in it because it may need a pocket to drop a square nut in or something like that. This type of feature generally has like a metal push tab that goes onto it, and you may need to change the size of it for whatever size feature that is. What I will say is that in most cases, when I'm dealing with parts that have like screw holes in a 3D print, or even an injection molded part, most of the time I'll put a chamfer on them. That's generally important to prevent it from cracking or splitting. And then also just be mindful of the number of traces or passes that you use for features like that, so that way you do have enough strength and thickness for actually creating threaded features. But I think that's, at least in my opinion, I think that's a pretty good representation of this part. Now, again, the design intent for 3D printing, it could certainly add more detail, like rounding some stuff off. If you've got little sections like this, we can use the delete key and let Fusion kind of patch things up if you have any problems internally. But we've got this divider wall here. We've got, features that can be used to hold whatever went in here. Again, it's probably some sort of pre-filter or screen or something like that. All this stuff can be adjusted and modified and added, but it keeps the same volume on the inside that the original had, or it's relatively close, I should say. And we've matched all the sort of geometry requirements on the outside for things like the inlet angle, the airflow sensor, and some of these other mounting tabs and bosses. The big difference, obviously, is this big chamfer on the bottom, because the ribs are just not needed for 3D printing. It would drastically increase the amount of time it takes to print, and they generally wouldn't turn out very good. So having something like this where it can build up as it goes would be much stronger for a 3D printed part. But if you want to add little ribs and features like that, you certainly can. All right, so if you have any questions on this, please let me know. As I mentioned, we are going to be doing a follow-up on this where we'll go into QuickSurface Lite and talk about some of the differences that we may have, different approaches, things that we may have done differently in that software. In general, the approach is still going to be very similar. This was a part where precision and accuracy wasn't really that important, right? So when we're doing things like making a triple clamp or a mechanical part, those are things that are very precise. We need to make sure that the diameters of certain features are perfect, and we need to make sure that all the features are in the right location. For something like this, there is going to be variations between these bolt holes and how parts fit, and the location of, for example, a hose clamp isn't critical. If it's shifted 5 millimeters one way or the other, that's fine. Things like these clamps, generally there's a lot of slop or variation in where they are, these tabs and so on. So, these are kinds of things that you don't have to spend a large amount of time trying to recreate just because they're there in the original part. You just have to kind of design for your end goal of manufacture and making adjustments. So once again, if you have any questions on this, please let me know. Make sure that you stick around for that bonus episode where we talk about the same part in QuickSurface Lite. We'll go over some of the tools that we want to use in there. And if you'd like to see this kind of content, please let me know that as well. I know we cover a lot on this channel, a bunch of different software programs, but also different topics and techniques, from building wireless phone chargers to 3D print and place fidget toys and everything in between. So we cover a lot, and it's hard to kind of meet everybody where they're at. But if you have any questions or comments, we always answer every comment that comes in on the video. So if we happen to miss one, then do apologize, but we do try to get all of them. So again, leave a comment. Let me know what you thought, what you want to see. And as always, thanks for watching, and we'll see you in the next one.